So we should also be familiar with the size and mass of atoms. So here we have drawn out the nucleus of an atom, and as we know, in the nucleus you have just the protons and the neutrons. What we're going to do is we're going to shrink this right down. Essentially, this gives us an indication of the size of the nucleus, and the reason why we shrunk it down is actually we want to draw the rest of the atom, and the rest of the atom would be much larger than the nucleus in terms of the space that it takes up. And so we know actually the rest of the atom is just going to be the electrons orbiting it. So over here we'll just draw one level of the electrons orbiting it. You could have several, but we're just going to draw one for now. And essentially what you need to know about is the atomic radius. And so atoms are very small, as I'm sure you are familiar with. And essentially we can take the radius from the middle of our nucleus to the edge of our atom, which is essentially the edge of where the electrons orbit. And the atomic radius of an atom is going to be approximately 0.1 nanometers. Okay, so that's equivalent to 1 times 10 to the minus 10 meters. So very small. And what we can say actually is that the radius of the nucleus of the atom is about 1/10,000th of that. And so we'll write that down. So if we were to take the radius of this would be 1/10,000th of the radius of the atom. Okay, and so essentially this would be equal to approximately 1 times 10 to the minus 14 meters. So you should know these approximate values: 1 times 10 to the minus 10 for the radius of the atom, 1 times 10 to the minus 14 for the radius of the nucleus, and that just gives you an idea of the scale of the size of the mass of the atom itself. And we can also talk about the mass of the atom. So just like we talked about charge before, we can introduce this concept of relative mass, and the reason why we want to use relative mass is because it's more useful to think about these very small masses in terms of how they relate to each other. So once again, we can have our subatomic particles. So we have a proton, a neutron, and of course an electron. And so what we can say, the proton has a relative mass of 1, the neutron has a relative mass also of 1, and the electron has a very small relative mass. We actually say it's negligible. It's so small, it's almost 0, and we can pretty much ignore it when we want to do any kind of calculation or anything like that. And so previously we talked about the atomic number being the number of protons, and actually what you might see in your periodic table, in fact what you will see, is your element. So let's take sodium for example, and you have two numbers. So you have a number here, it's going to be 23, and a number over here which is going to be 11. And we've already covered this number at the bottom. So this is what we call the atomic number, and as you mentioned before, this gives you the number of protons in the atom. And actually this number over here is what we call the atomic mass, or the mass number. And the mass number essentially gives you the number of protons and the neutrons. And the reason for that is if we have the proton having a relative mass of 1, and the neutron also having a relative mass of 1, then obviously if you add them together, then what you end up with is the total mass number. So this is actually the number of neutrons and protons combined. Okay, and so hopefully the keen-eyed amongst you will have noticed that over here we have the number of protons, and over here we have the number of neutrons and protons together. So if we combine the two, we can actually work out the number of protons and the number of neutrons in any atom if we have the numbers like this. And as we mentioned before, usually with atoms the number of electrons is the same as the number of protons, and that's why the atoms are generally electrically neutral. They don't have a charge. But if you do have an atom with a charge, so you could have sodium over here, and again 23 and 11, and you could have a charge of, let's say, -2. What that means is that because you have a negative charge on your atom now, that means you've gained 2 electrons. Remember, you have a -2, the relative charge of an electron is -1, so you've gained 2 electrons to give you a charge of -2 overall. Instead, you could have a positive charge of +3. What that means is you've lost 3 electrons. So if you lose 3 charges of -1, that means you have an overall charge of +3, because now your number of protons outnumber the number of electrons by 3. Hopefully that makes sense. And the final thing we want to cover is isotopes. And so what do we mean by an isotope? Well, essentially we already said that how we define an atom is by how many protons it has. So anything, for example, sodium here, anything with 11 protons is called an atom of sodium. But we have just seen that there's another number here, this 23, which is the atomic mass. Now that can change, and you can still call it an atom of sodium. So for example, we have Na, and we could have 23 and 11, but we could also have another sodium, and again it has to have a proton number of 11 because that's what makes it sodium. But let's say this time the mass is 24, and we can take another one, and let's say this time the mass is 25, and again the proton number is 11. So this is what we call isotopes of sodium. So these are all isotopes of sodium, and essentially they have the same proton number but a different number of neutrons, which gives them a different mass number. Okay, so that's what we call isotopes of that element. So let's go ahead and do some questions to see what you guys have remembered. Okay, feel free to pause the video and have a go at these questions. You may need the periodic table to help you out. So question 1 then, work out the mass number of an atom of sodium with 15 neutrons. And so if we actually are going to put in the periodic table here, just to show how we use it, bring it in over here. So sodium, we can see, has a proton number of 11, as you just mentioned before. And therefore, if the atom of sodium has 15 neutrons as well, then the total mass number would be 11 protons plus 15 neutrons, and that should give you 36 for the mass number. Okay, so it would be an isotope of sodium, a very heavy one. How many electrons in the following? So here we've got an atom of oxygen, but it's got a 2+ charge. So if you see oxygen over here in the periodic table, it has a proton number of 8. So usually the number of protons equals the number of electrons, and that's why you have no charge. In this case, we have a 2+ charge, but the number of protons doesn't change because it's still an atom of oxygen. If you change the number of protons, it will become a different atom. So we know that to get a 2+ charge or any charge, it has to be the number of electrons that are changing. And so if we have a 2+ charge in this case, that means that we have lost 2 electrons because we have a net positive charge, right? And so if you lose 2 negatively charged electrons, you end up with a 2+ charge. And so usually you'd have 8 electrons for your 8 protons. So instead you do 8 minus 6, and you should get an answer of 6 electrons. Okay, same approach here with lithium. We have a 3- charge this time. So lithium has 3 protons, so usually you have 3 electrons, but in this case you have an additional charge of 3-, so you do 3 plus the 3 additional electrons you need to achieve your 6 electrons. Okay, and the last one here is Sc, so you need to find Sc. Scandium over here has a proton number of 21. It has a negative charge in this case. We know we need 1 more additional proton, and so we'd have a total number of electrons of 21 plus 1 to give you 22 electrons. Okay, so hopefully everyone got those ones correct, and I'll see you in the next one.